Hi folks. So today I wanted to talk to you about the joints of the upper extremities, or in other words, the joints of the arm. And before we look at specific joints that I want you to know for your anatomy test, let's talk a little bit about some structural categories of joints, some structural ways that the form can follow function, can follow form. So if we look at the types of motion that different joints allow based on how they are structurally composed, we can look at a few basic categories, and we'll talk about this in more detail when we get to our chapter on joints. But we're going to look at plane joints, hinge joints, pivot joints, and ball and socket joints. And then for some a little sort of modification of the ball and socket, we are also going to have the ellipsoid, also called condylar or condyloid joint, and the saddle joint. So let's take a closer look at each of these, and we'll start with the plane joint, which is basically two flat surfaces sliding against each other. So here we can see basically a simplified GIF of a plane joint, where rather than a particular axis of motion or controlled range of motion, this synovial joint is just two flat surfaces moving against each other. And that is called a gliding motion rather than an axial motion. So it has zero axes or non-axial motion, it glides instead. And so here you can say because of that gliding, they can slide back and forth in all directions, they can rotate, they can sort of do anything that involves those flat surfaces gliding. So examples of where you would have these in the body: between the various flat surfaces of the carpals in your wrist or the tarsal bones in your ankles. These flat bones are all kind of clustered together in a big clump, and so as your wrist twists and rotates, those flat surfaces glide against each other. Now, this is going to be distinct from the actual motion of those carpal bones against, for example, the rest of your arm, your radius and ulna. That's going to be a different type of joint, but between each other, we get these gliding surfaces. So next, let's look at something that creates a more limited, more axial type of motion. Let's look at a hinge joint. So a hinge joint works just like the hinge on a door. And this allows, you can see, one axis of motion back and forth, or in other words, flexion and extension. Flexion is what happens when that angle shortens and the joint bends. Extension is what happens when that angle straightens out or increases and the joint straightens. So flexion and extension are opposing directions of motion, but they're on the same axis. And hinge joint allows flexion, extension, flexion, extension. Now, in order to create this motion, you're going to need a muscle on each side of the joint. Muscles on the front of the joint will shorten and flex that joint, and then you'll need a muscle on the opposite side of the joint in order to shorten and pull that joint straight again or extend it. So you're always going to have a muscle that only does one of those two halves of the axis, because you can only shorten muscles. So classic example of a hinge joint is going to be how the trochlear notch of the ulna, that socket wrench shape of the ulna, fits into that trochlea or pulley system on the humerus. And so when they fit together like that, just like a hinge, we create that hinge motion of the elbow, which is the ability of the elbow to flex, extend, flex, extend. So the joint between the humerus and the ulna will be a hinge joint. Now let's look at a joint that is also a single axis of motion, but it's going to be a different axis. It's going to be along the long shaft of the bone. Now this is going to be called a pivot joint. And before I specifically show you a pivot joint, let's look a little bit about how these joints are structured in the body. A pivot joint has a cylinder or rod-shaped bone that's fit into a ring or half ring of another bone, so that the rod or cylinder bone can rotate along its shaft or its long axis within that ring. A lot of times this ring of bone is closed by a tendon to really get a full loop. So now let's look at this in GIF form. here we have a pivot joint, a ring and a rod. And the rod can rotate. That's its single axis of motion. Remember, rotation always happens along the long shaft of the bone. It's distinct from circumduction, which is going to be a combination of extension, flexion, and abduction, adduction. That creates the circumduction, which is what you might be thinking of when you think of rotation. The actual twisting of the bone along its axis, that's rotation. So that is our other single axis of joint. And a really important place where this type of joint, this pivot joint, is located in the body is within the forearm at each end of the radius and ulna. And the combination of these two pivot joints is what's going to allow the radius and ulna to pivot into a supination or a pronation. So let's take a look at how those work together. So here you can see a close-up of the bones of the forearm, and we are going to have a pivot joint right up here between the ulna and radius, and a pivot joint at the distal end between the ulna and radius. And the combination of these two is what's going to allow supination and pronation. So you can really see the pivot structure really nicely up here, where the rod-shaped head of the radius is nestled into a semicircle notch in the ulna. That's called the radial notch, and then really held in place by a loop of, that would probably be ligament there. And then at the other end, again, we have here a rod-shaped ulna nestled in a half-circle notch of the radius. That's the ulnar notch that is on the radius. So two pivot joints. Let's watch these in motion now. And you can see as this radius up here, as it rotates along its length within that ring, that's our pivot. And the combination of these two pivots creates supination and pronation. Finally, let's look at a multiaxial motion. This is going to have flexion, extension, it's going to have abduction, adduction, and it's going to have rotation. And all of these are being modeled here for you. So it has many, many axes, almost, you could think of it almost as full range of motion, although obviously it's not completely full range. This is a ball and socket joint, and it's named that because we literally have a ball sitting in a concave dish called a socket. And so this combination of ball and socket allows really wide range of motion. The bone can twist along its long axis, it can go back and forth, that would be abduction and adduction, and it can go forward and backwards, that would be flexion and extension. And if we combine abduction, adduction, flexion, extension, you can also get this circumduction, which we'll see here in a minute. That's circumduction. We're combining several of those motion axes at once. So this is really going to provide the widest range of motion of many of our joint types, and you'll see these in areas where we use a lot of range of motion, in particular up in our shoulders, where our humerus sits into the glenoid cavity of the scapula, and you'll also see it down in your hip with your femur nestled into your hip bone. So before we go ahead and talk about specific joints in the arm, let's go ahead and look at two sort of modified ball and socket joints. These are going to be our condyloid / ellipsoid and our saddle joints. So this is a ellipsoid joint, also called a condylar or condyloid joint. I like ellipsoid because it really conveys what you're looking at. It's basically a ball and socket, but the ball and socket are more oval shaped or ellipsoid shaped. An ellipse is an oval. And because of that oval shape, we don't get quite as full a range of motion. It's going to lend itself a little more to a forward backwards, almost like a hinge, with a little bit of that side to side and circumduction allowed as well. But it's slightly more focused on being a hinge. And a place where you have these ellipsoid joints is in the knuckles of your hand, which are primarily hinges, but they do allow abduction, adduction, and circumduction. So we have a big range of motion, but it's a little more focused on really getting a nice hinge in there. Now, the final type of joint I want to show you is essentially a modified ellipse, and this is going to be a saddle joint. So here we have a saddle joint. You can see it's sort of gets its name because the ends of each bone look like a saddle, like two saddles nested against each other, two U shapes interlocked. And this joint is somewhat rare in the body. The primary example of a saddle joint is going to be the base of your thumb. And that saddle joint is what allows your thumb to be opposable and come inwards like that. So the opposition of the thumb, the opposability of the thumb is created by this saddle joint. But you can see again, this is some nice multiaxial motion, but it's a little more focused on creating that a little bit of a hinge in two different directions, a little less circumduction, but you can certainly still do it. So here I've put up just sort of an overview or a front view of the skeleton where we can see sort of the range of the arm. And there are, of course, multiple joints, many joints in the upper extremities, but we're going to pick a few to focus on. So we're going to look at 5 important joints in the upper extremities. We're going to look at the joint between the scapula and the clavicle. So right here, this is the acromioclavicular joint. We're going to look at this ball and socket joint of the shoulder, which we're just going to call the shoulder joint, where the humerus sits in the scapula. We're going to look at that hinge joint of the elbow. Again, we're just going to call this the elbow joint. That's the humerus, the trochlea the trochlea of that humerus with that ulnar socket wrenching onto it. So we get a nice hinge joint. Then we're going to look at the 2 pivot joints of the forearm. These are going to be the proximal radioulnar joint and the distal radioulnar joint. Both of those are, of course, between the radius and the ulna. Now, there are other joints in the arm, especially when we get into the hand. We have the wrist, we have the joints between the carpals of the wrist, we have the knuckles we talked about a little, we have the hinge joints in the fingers, we have the base of the thumb and the hinge joints in the thumb. So there are plenty of other joints going on in this arm, but we're going to focus on these key 5 joints. So let's start by taking a closer look right up here at this acromioclavicular joint. So here's a close-up of that shoulder anatomy. We have the clavicle or collarbone. We have the scapula or shoulder blade with its acromion process, that high point of the shoulder. And then we have the humerus. And let's look specifically at this acromioclavicular joint between the scapula and the clavicle. So the articulating bones are, of course, the scapula and the clavicle, specifically the acromion process of the scapula and this acromial end of the clavicle. This is considered a plane joint. We have 2 flat surfaces that can glide against each other. There's also some allowance for some rotation, because remember, plane joints can slide around and rotate, but this is all non-axial motion. Next, we can look at the shoulder joint down here. We don't even have to move off of this picture, and we have the head of the humerus, that big rounded ball sitting in the socket of the scapula. That is the glenoid cavity. So the articulating bones of the shoulder joint are the scapula and the humerus, again, specifically the head of the humerus and the glenoid cavity of the scapula. That's our ball and socket. So this is a ball and socket joint. Remember that ball and socket joints provide a wide range of multiaxial motion. We can flex, we can extend, we can abduct, we can adduct, and we can rotate. So try those motions out really fast. We can flex, we can extend, we can abduct, we can adduct, and we can rotate along the shaft of that humerus. So all together we can do things like circumduction and do all sorts of fun things with our shoulder. This is one of the joints that has the widest range of motion in the body, and we've actually sacrificed some stability of this joint in order to create that really wide range of motion that lets us do really cool things with our arms. And that's also why this is the most frequently dislocated joint in the body. Because it's so flexible, it's also a little shallower, a little less stable, and that means it can pop out of the socket. So now let's take a nice up close look at the joints in the elbow. In particular, let's look at the elbow joint, which we're going to look at the connection between the ulna and the humerus. So remember, these two bones articulate with the trochlea of the humerus. That's this sort of rounded area the ulna can fit onto right here. And then down here we have the trochlear notch, that socket wrench shape that is wrapped around it with the ulna. So let's look at this in real bones for a minute so we can remember how this works. So we have our humerus with its nice rounded head, and then on this end we have a trochlea for the ulna to articulate into, and the capitulum for the head of the radius to articulate with. And this trochlea is what's going to create that really nice hinge joint. Now, if we look at the ulna, we have a very socket wrench shaped bone. And in fact, that socket wrench shape is caused by this trochlear notch, which is going to grab onto the trochlea. So if I get this bone here, oh, I've got it backwards, and I put these together, they're going to sit right together like that, and that is our hinge. So now we have a really nice hinge. We can flex, we can extend. And in the back of this bone, we have a very nice fossa. This is the olecranon, the point of the ulna. The olecranon is the point of your elbow. And that olecranon can sit right into this olecranon fossa when the arm is all the way extended. So flex, extend, and we have a nice hole in the back for those to fit together. So we get a really nice motion with this hinge joint of the elbow. All right, so that's the elbow. Now let's, excuse me, let's look at the slightly more complicated pivot joints that occur at each end between the radius and the ulna. So I already showed you a video of this, so I'm just gonna go ahead and grab my little skeleton friend and we'll take a peek at that motion on him. So here's my skeleton friend, and we are looking not at this hinge joint of the elbow, we are looking at the pivot joints at each end of the forearm that occur between the ulna and the radius. And both of these pivot joints, one is going to have a rod and a notch, and then on the other end we're going to have the opposite one be the rod and the notch. So those notches, remember, can get kind of confusing when we name them, because up here we have the rod of the head of the radius, that rounded head, sitting into a notch on the ulna, and that notch is called the radial notch. So the radial notch is on the ulna. On the other end, we have the rounded distal end of the ulna sitting into a notch on the radius. So the ulnar notch is on the radius. So don't get confused. Radial notch is up here on the ulna. Ulnar notch is down here on the radius. They're named for what fits into them. And so here, this radius can twist inside that notch. It can pivot, rotate along its axis. And down here, the ulna can rotate within that notch. And the combination of those two motions is what creates that supination and pronation. So remember, soup, you're serving soup. Pronation, the bones cross. Now you're dribbling basketball like a pro pro basketball player. Uncross, supination. Cross the bones, pronation. So that is our proximal radial ulnar joint, means up high. Remember, proximal, closer to the origin of the appendage. And our distal radial ulnar joint. Radial ulnar because it has the radius and the ulna. Proximal radial ulnar, distal radial ulnar. And those are all the important joints that I want to review for this. So the last thing I want to remind you is that we will talk in more detail about structural and functional classifications of joints when we get to our joints chapter. And so in future anatomy practicals, I am going to expect you to know the structural and functional classification of each of these joints, and that is distinct from the type of motion they allow. And fortunately, this one's really easy to remember because all of these joints we're looking at are structurally synovial and functionally diarthrotic. What does that mean? Well, most of the joints in your body are synovial joints. These are going to be the joints that have a capsule filled with fluid. Synovial literally refers to ovo, like egg, like an ovum, and it means literally it's an egg joint. It's a fluid-filled capsule. And these are honestly most of the joints in your body. So almost anything you think of as a joint, with the exception of some of your cartilaginous joints, most of these big motion joints are synovial. And we'll talk about what that means down the line. Functionally diarthrotic, what that means is it's a broad classification for how much movement the joint allows. And all synovial joints are diarthrotic, and diarthrotic just means lots of movement. We can now subclassify diarthrotic into things like pivot, or, sorry, I did pivot and I used a hinge joint. Hinge, pivot, ball and socket. Those are subclassifications for synovial diarthrotic joints. But all of the joints we're looking at are synovial and diarthrotic of these 5 we looked at in the arm. All right, so I'm going to call it here for this, and then the next recording you'll see me in, we will talk about the nerves of the arm.